Hi, physics. Mr. Janowski here. I'm going to show you how to do some trig problems and some inverse trig problems. So here we are on homework 5. I'm sorry, chapter 5, homework 1, problems 1 and 2. So what are we looking for here? Solve for the unknown side indicated by the x. Okay, so first let me cross out the program that makes these things, labels the corners A, B, and C. We don't need that. So here we are, problem 1. And we want to figure out x. So when you get a problem like this, the first thing you should do is label all of the sides. So this is a right triangle. 12, this is the longest side of the right triangle. So this is definitely our hypotenuse. So that one is h. So which side is O and which side is A? Well, in this case, we're going to work with this angle, the one that says 56.3 degrees. So that's theta. So this side x, is this the opposite or the adjacent? Well, adjacent means next to. So this side is next to the angle. So this side is A. And that means this side over here, the one that is opposite the angle we're going to work with, that one is O. So in this case, I know theta, I know h, I want A. So which trig function does theta, A, and h? It is cosine. So your next step should be write the definition of cosine. Cosine theta is A over h. And we're trying to solve for A. So what we want to do is multiply both sides by h. That would give me h times cosine theta on the left. And on the right, I have A. And where are we going from here? Okay, so what is h? H is 12 times cosine theta. So times cosine of 56.3 degrees. So please make sure that your calculator is in degree mode, not in radian mode, or you will not get the right answer for this. I can help you with that in class if you need it. So 12 times cosine of 56.3 is equal to A. So I can do that very quickly in my calculator. 12 times cosine 56.3. And you end up with 6.66 is equal to A. So that's what A is equal to, 6.66. Going on to problem 2. So what's going on over here? First of all, label your sides. So over here, the side that's 11, that's definitely the hypotenuse. That's the one opposite the right angle. It's the longest side of this triangle. We're going to work with this angle up here at the top. So 45 degrees, this is equal to theta. And this side that we want, x, what is this? Is this adjacent or opposite? This is another one where it is adjacent to the angle we want. So this one is A, making this one O. So once again, we have h and theta. We want A. So which trig function is it that does A, h, and theta? That again is cosine. So that's the way this worksheet worked out. Randomly generated. I kind of wish it had worked out differently. But anyhow, you want to start in the exact same place. Write down your definition of the trig function you're going to use. Cosine of theta is equal to A over h. The thing we want is A, so multiply both sides by h. H, cosine theta, is equal to A, which means in this case, 11 times cosine of 45 degrees is equal to A. So in the calculator, 11 times cosine 45. All right. So there is something useful to learn here. What my calculator did, my calculator is trying to be helpful. So it told me that the answer here is 11 root 2 over 2 is equal to A. So my calculator is trying to be helpful. If we were doing math class, that's the kind of thing we would want, perhaps. That's the exact number. But in physics, like in engineering, we want the decimal. We want to know what this actually is. So there's a couple ways you can do that. One is I can multiply that number by 1.0. That would tell my calculator, don't give me the exact answer with the square root. Give me the decimal. The other thing I can do is on my calculator. So if you happen to have my calculator, which is the TI 36x Pro. Right above the Enter button at the bottom right, there's a button that looks like this. So there's an arrow going that way, a little arrow going that way, and a wavy equal sign. So that's what the button looks like. So you may have a different calculator. You may have a completely different button for this. But if I hit that button, what it does is it turns me from this perfect fraction into a decimal. And the decimal is 7.77817. So I'm going to round off a little bit, 7.78. So that's my answer for that. A is equal to that. So again, to get from this annoying 11 root 2 over 2 into a decimal, either just multiply it by 1.0. That would do the trick. Or you can just hit this button if you know what that button is in your calculator. So that's how you can do that one. Now let me skip ahead. Oop. So we've done 2 trig problems. Let's do a couple of inverse trig problems. First, let me get this guy here. All right. So we'll do 7 and 8. So for 7, let's see what's going on here. In these problems, let me cross these guys out again. Boop. All gone. All right. In problem 7 through 10, you know 2 of the sides and you want to figure out the angle. So this is the time to use inverse trig. So I'm going to label my sides here. So this side here is 6. This is definitely H. That is the longest side of my right triangle. That's the hypotenuse. This is the angle we have here. So this side that says 5, is this opposite or adjacent? Well, it's not adjacent. It's not next to this angle. So this must be the opposite side, which makes this one the adjacent side. So in this problem, I know H, I know O, and I want theta. So which trig function does O, H, and theta? It's sine. So the way I would do this, I'm going to take it in little steps. I would start with the exact definition of sine. Sine of theta is opposite over hypotenuse. So if I knew the angle and I knew one of the sides, I could use this to solve for it. In this case, I know both of the sides here, and I want to know the angle. So now is actually the time to use inverse trig. And the way inverse trig works is inverse sine of O over H is equal to theta. So the way this works, when you're doing the inverse thing, the inverse trig function, this guy here goes over there. Sorry, I'm trying to draw an arrow. He goes over there. And this guy here, he goes over here. So they kind of switch what's going on there. So what that really means is in the calculator, what I'm going to have is inverse sine of O over H. O is 5. H is 6. And this will be theta. So ask your calculator how to do inverse sine. On mine, TI-36X Pro, inverse sine is just hit the sine button twice. Your calculator may vary. So anyhow, somehow get to inverse sine, do 5 divided by 6, and I end up with 56.44, et cetera, et cetera. So I'm going to round it off to 56.4 degrees is equal to theta. So there's my answer for that. Moving on to problem 8. So in this case, let's see what we got. Well, first let's label our sides. So there's H. Here's the angle we want. So 5.1, is that the opposite or the adjacent? Well, 5.1 is next to it. So this is A, and over here, this is O, which means I have O and A, and I want theta. So which trig function does OA and theta? The answer is tangent. So tangent theta is equal to O over A. Opposite over adjacent. So I'm doing this a little bit the long way around, but honestly, this is how I think of it. Before I think of inverse trig, I want to think of the regular trig first. So in this case, I know O and A, I want theta, which means what I'm really trying to do here is inverse tangent of O over A is equal to theta. So try to convince yourself. No, not convince yourself. Look at how this line here relates to this line here, and what happened and where things moved when I went from tangent to inverse tangent. The right side became what is called the argument of inverse tangent, and the theta over here, well, that now became the right side. So that's what we've got. So what I want my calculator to give me is inverse tangent of O over A. So O is 10, A is 5.1, and this will be equal to theta. So ask your calculator, inverse tangent 10 divided by 5.1, and it will give you 62. Here's what I got. 62.9784, et cetera, degrees. I'm going to round this off. When you round this off, you end up with 63.0 degrees. If you round it off to the nearest tenth of a degree, is theta. So that's how that works. So we've done a couple problems with trig, meaning we knew one side and the angle and we wanted a different side. And now we've just done two problems with inverse trig, meaning we started off knowing two of the sides and we wanted the angle. So that's how you do these. And hopefully you guys found that helpful.